Okay, so before we start today, I want to acknowledge with respect the Indigenous peoples and communities whose historical relationships with the land continue to this day and on whose traditional territories our work takes place. While we meet today on a virtual platform, we can take a moment to acknowledge the importance of these lands, which we all call home. We do this to reaffirm our commitment and responsibility in improving relationships between nations and to improving our own understanding of local Indigenous peoples and their cultures. So my name is Autumn Sipus. I am the project manager for the Canadian Coalition of Green Healthcare. And on behalf of the coalition, I would like to welcome you to today's event, Empowering Healthcare, how Horizons Energy Evolution has led to resiliency. This webinar is being delivered as part of the coalition's Preparing Canada's Healthcare Buildings for Net Zero project, made possible with an investment from the Government of Canada's Low Carbon Economy Implementation Readiness Fund. Throughout the event, please use the chat function for any technical issues you may be experiencing. Please feel free to introduce yourselves and create any conversation in there. And then we would ask if you would please use the Q&A function for any questions you have regarding the presentation. And our panelists will be answering the questions at the end of the event today. We are also recording this presentation, and the recording will be sent to all registrants and will be available on our website and YouTube channel at a later time. So, presenting today, we have Brent Godbout. Brent is an energy manager with Service New Brunswick Health Services Division and has been working with Horizon Health Network to provide energy expertise since 2020. He has a passion for energy management and greenhouse gas emission reduction, especially pertaining to healthcare facilities, and has experience in leading energy opportunity projects. Brent is a registered professional engineer with APEGNB, a certified RET screen expert, and a member of the Canadian Healthcare Engineering Society. All right, take things away, Brent.
Welcome, everyone. Let me share my screen. Did that pop up okay?
You may need to try again. I think maybe when you first tried, I still had my slides shared. There we go.
Okay.
Beautiful.
All right. So let me move a few things around. Okay, yeah. So welcome, everyone. Today I'm going to give a quick presentation. It's Empowering Healthcare, Horizons Energy Evolution. Going to go over for about 15 minutes I guess we'll call it the theory or the energy network that we have created within Horizon, and some of the methodology we go about to do energy management. And then I'm going to go into 3 case studies to sort of showcase how we go through it, some of the challenges we've gone through, and also just to reiterate all of the upfront stuff that I present on, the methodology that we go through. Let's dive into it here. So Horizon Health Network consists of about 28 healthcare centers here in New Brunswick, 12 hospitals. Annually, we use about 23.2 million in energy costs, and that equates to about 211 million equivalent kilowatt hours annually. And GHG emissions were a little over 44,000. So the Horizon Energy Network, we have 4, I guess, regions within Horizon. Each region has a member that sits on the energy network. I also sit in the energy network. It was created 12, 13 years ago with senior management support. Our mandate is to provide leadership and direction in the reduction of consumption of energy and resources for all Horizon facilities. Our mandate is in alignment with the government of New Brunswick's climate change action plan. In that action plan, they have a number of GHG reduction goals, and it's also in alignment with government mandates such as the health minister. We have a mandate to reduce GHG emissions and meet the 2035 goals, which include several goals to when it comes to EVs and converting our fleet to EVs. Results over those 12 years cumulatively, we've saved or had a cost avoidance of about $29.2 million. That's come at an investment of $25.5 million. Equates to about 407 million equivalent kilowatt hours of energy, which is the same as about a little over 13,000 homes. And GHG emissions, we've reduced by about 31,800 e-tons of CO2. That's the equivalent of about 28,000 cars off the road. So fairly significant numbers, and we've had quite a bit of success for sure. So empowering energy management culture, we talk a lot about this people, information, technology triangle. The information part is your energy data, all of the tools you use to showcase each facility and each hospital, how it's doing, not only in relation to one another, but even hospitals across the province. We'll get into some of the tools that, across Canada. We'll get into some of the tools that we use. Then there's the technology side where, it's all the measures that you're implementing. So whether you're doing heat recovery projects, lighting projects, biomass boilers, whatever the case may be, that's the technology part. And then, of course, there's the people. That's what sort of holds it all together. That's what makes the whole triangle work. And it wouldn't work without the people. Methodology that we use is this continual improvement process. This is rated of ISO 50001. You have to have management commitment up front. As I was saying, it was the management commitment that sort of started this whole energy network that we have within Horizon. So without that support, it just wouldn't get the traction that you need, the funding, and the commitment and trust from everyone starts right at the top. Once you have that, you have to assess your current situation. So that's seeing where each of your facilities or each of your hospitals sits, again, with relation to each other and others across Canada, helps you give direction on where to start and which facilities are, we'll call them the poor behavior or poor users, and where you can really make the biggest gains. Once you know that, you have to set your goals and targets, not only yearly, but even we have a 5-year plan where we have targets and goals that we're trying to achieve. Then you implement projects, whether it's, projects within the facility or even operationally. You can definitely make big gains when it comes to how you're operating your air handling units and using energy within your hospital. And then you have to check. So you have to do measurement and verification on your projects. That's very important to determine, which projects saved lots of energy and you achieved the savings you sought out to achieve, and also ones that don't do as well as you thought. That's important because obviously you're going to replicate the ones that do well in other hospitals, whereas the ones that don't do so well, you will make sure you try to figure out why, and you probably won't implement them at other facilities. And then, of course, you have to review, evaluate, and celebrate. Celebrating your achievements and successes is really important for awareness. We celebrate our successes a lot. We send newsletters out to all of the Horizon employees just to bring awareness up on the achievements that we've had, and it just helps build momentum. And then, of course, this is a continuous process. You can't just go through this once and then say, job done. It's a continuous process that you're constantly reviewing. Just to sort of reiterate this continual improvement process, this is one of our hospitals. I have a case study that gets into this facility a little deeper, but this is our total energy in equivalent kilowatt hours. And you can see back in 2012, 13, we had done some projects back there, decreased energy, and we're doing reasonable all the way up to 2019. Then we had this 4 or 5 years in a row where we were increasing energy, and it took us a while to figure this out. The case study I go over gets into it, so we'll see a bit more of it. But we did finally figure out what was going on, and you can see 2024 we're back down again to the levels we had expected previous to that increase. But it just reiterates the fact that you have to be constantly watching your energy, monitoring your energy, and looking into all this stuff. The energy management challenge. Lack of information is obviously a huge challenge. You have to be tracking your energy, and whether you haven't done any of that or you're, doing some of it, you just need to make sure you're doing it well, because without that information, it's really hard to, showcase successes and know where to start. Which hospitals have more opportunity than others. If you have a hospital that's doing very well energy wise, and that's obviously not going to be the spot where you would start compared to one that's not doing quite as well when it comes to your energy performance. Awareness and understanding is key as well. Like I said, um, showcasing the successes and even the challenges. We discuss all the challenges and successes we have within our energy network continuously. We meet 4 or 5 times a year in person sometimes to go over all that and just raise awareness. And then, of course, sending all that stuff out in newsletters. I consistently will send out challenges we've gone through and then found a solution to it. I'll send that out to the whole facilities group just to make sure other hospitals who come into the same sort of thing will be able to remember that and hopefully solve it quicker. And then competing priorities is huge. Everyone knows how busy facilities folks can be with competing priorities. So you need to set this up so that, what we found is the chief engineers and a lot of the facilities guys, they can't do this energy management on a full-time basis. They just don't have the time. So our group and myself with Horizon, I'm the one that makes sure all of our energy is in the tools. I do energy management on a daily basis. And it's because of that. It's because the competing priorities make it really hard for someone within the facilities group to do it well. So that's a big one, is the competing priorities and setting it up so that it's not forgotten about. So let's get into some of the tools that we use. This is Energy Star Portfolio Manager. It's an Enercan run tool. It's free and available on their website. It does take some time to get your energy data into the tool, but it's not overly challenging. I think the biggest challenge is making sure you have all of the utility data from the different utility providers. But once your information's in there, the best part about this tool is it's very simplistic. It's easy to use and understand. I give access to anyone within our facilities group if they would like access to their hospital's energy use, so they can go into this tool and look at it and review it. I can set them up with a free version, read-only version of the tool, and they can go in and look at their electricity energy, their natural gas energy, whatever they want. And usually I can do that within 30, 45 minutes. I set up a little webinar kind of thing, and so that's the best part of this tool. It's great to start with this tool. If you haven't done much energy management, you're looking for a tool to get started with, this would be a good one to start with. Then diving in a little deeper, there's RetScreen. RetScreen's more for someone who does energy management on a daily basis, like myself. It's a bit more sophisticated. There's, courses like RetScreen Expert, which take 3 days to go through, and there's a lot to this tool, but it's a very powerful tool for someone who does energy management on a daily basis. It's great for measurement and verification of your projects, things like that. This is an example of what you can do within RetScreen. Like, this is just monthly electricity data. This is our monthly natural gas data at this facility. But when you get into this bottom chart, it's a regression analysis. This is actually called a Q-sum. Basically, you pick a baseline. So the baseline is before this red line. The 12 months before is my baseline. Usually you want to pick that when you're not doing a great big expansion at your hospital, and you're not doing a whole bunch of projects. And then you start comparing yourself to that baseline as you move forward. So in this case here, the natural gas one's a little easier to look at, but we have our baseline, and we did a stack economizer project. At the end of that baseline is when we implemented it. And you can see after we implemented it, we're going down in energy. So if the slope of your line is going down below the zero axis, it means you're saving energy compared to that baseline that you chose. If we had just continued going along the zero axis, it would have meant we're using the same amount of energy as our baseline, which would have made us question, why aren't we seeing savings with our stack economizer? So that's the power of this tool. The other thing I should mention is it's weather normalized. So any of the trends that happen in this tool are not because of weather. So if you have one winter that's colder than another one, this tool accounts for that. So I know that these savings are not because of weather, they're because of the stack economizer in this case. That's why we're saving energy. So it gives you a little bit of an insight to this tool and its value. We also do have our operations group, building automation systems. They can go in and look at this. It can show yearly data. This one up here is daily or monthly data. So the colored lines are current year and the gray ones are the and it gets right down into to hourly data. So you can see here the hourly data. In this case, this is natural gas. Overnight, this is our temperature line right here. And we're going down to 10, 11 degrees, minus 10, 11 degrees. And we're using a little bit more natural gas each hour. And then in the morning, temperature warms up, we get up above zero. And now all of a sudden you see we're not using quite as much natural gas. So it shows you the power of some of these tools that are operations groups, and myself, I also look at these. But that kind of gives you an idea of the level of tools that you can use. We use all of these, but we've been at this for quite some time. So depending on where you're at, that'll sort of depict which ones you choose. Getting into the people part, like I was saying, you have to have leadership buy-in. Without it, it's just not going to run smoothly, and you're not going to get the upper management support that you need to run a successful program. Operations, they do daily checks, so they're very key to all this, right down through to myself, energy manager. I'm the one that sort of does this on a daily basis and make sure we stay on top of it, make sure we're doing M&V on our projects. And if it's done well and you've raised awareness within your, whatever your hospitals and within the groups, it'll trickle right down to staff. Will take things on themselves. And good example of that is we had a project that we were doing at a smaller hospital. We were doing some reprogramming of our HVAC units where we had a bit of simultaneous heating and cooling going on. So we were trying to reprogram our HVAC units to stop that. We had one facilities person that was, she was involved in the project and became quite, I guess, enjoyed it quite a bit. So she took it upon herself in the mornings to start doing walkthroughs of the hospital just to look for little things that, lights that were left on or things like that. And she came across a nurse station that several mornings she found. It was the middle of the summer, and she was finding the window was wide open right next to their nurse station. So she went and questioned them on it. She said, "What's going on? Like, we're trying to cool a facility, and you guys keep opening your window overnight." And the nurse said, "Well, we've got an intake vent right above us that's blowing cold air directly on us. So we all get cold and we open up the window." So this facilities person took it upon herself to go get a diffuser and put the diffuser and make the that cold air blow across the ceiling and down the back wall instead of directly on top of them. So, but it just goes to show, if it's done well and there's lots of awareness, staff will take it upon themselves to do things like that, which is great. So to wrap all this, upfront stuff together, if your energy management program has to provide a framework, it has to, organizational commitment, right from senior leaders all the way down through. It has to, like I said, engage all levels of the organization. It has to have well-defined roles and responsibilities. We all know our roles, and my role is to make sure I'm tracking energy and making it apparent and making everyone aware of it, coming up with projects. Um, you know, it's hard to give that to facilities folks because of all the competing priorities that we talked about. Needs to evaluate energy for performance, of course, using all the tracking tools that we've talked about. Needs to communicate the information. It has to come up with energy performance improvement opportunities, of course, and it has to be a continual improvement process. So that's it for the upfront stuff. I'm going to go through 3 case studies now to sort of showcase all that upfront stuff. And hopefully at the end of it, you'll have a better understanding of, the communication, the challenges you go through. Energy management doesn't always come easy. So first one is Upper River Valley Hospital. I'm an engineer. I tried to come up with creative names for each of these. This one I called Enduring Teamwork. This hospital was built in 2007, originally built with oil boilers. And in 2021, the end of 2021, we commissioned a pellet boiler at this hospital. So there's our big pellet hopper, holds all the pellets. They come down in, auger takes them up into the pellet boiler building, puts them into the boiler, and then ash comes out into these bins. This is the old design. I'm going to get into that a bit. Sorry. This is a video. It works. So there's the firewall at one end of the boiler with the pellets. The ash all comes down this conveyor belt. All that combustion gases and heat go up into the upper part of the combustion chamber and gets transferred to the hot water tubes that are above this. That hot water goes over to the hospital, goes into a heat exchanger where it gets exchanged into the hot water loop, or the heating loop of the hospital. So this pellet boiler, like I said, it was commissioned in December of 2021. These brighter red lines, we'll call them, are 2021 data leading up to that commissioning. And then December was our first month where we commissioned the boiler. Over Christmas time, not the greatest time to commission a boiler, but we did it. And you can see we used more energy than we expected. The first back in here, this is like 2016, 17, we did a big recommissioning project, which is why you see the big drop in energy in following years. So that's what that first big drop is. But then once we commissioned the boiler, we're almost back to what we were using before, which isn't what we wanted, obviously. Then leading into 2022, this duller red line here is 2022, so that's January and February. We're definitely using a lot more energy. It's not what we wanted. This is the cumulative sum from RET screen that I was showing you. So here's our baseline prior to doing our recommissioning project. And then afterwards, we start comparing ourselves to that baseline, and we're going down, which we expected. We did a big recommissioning project. Doing fairly well. Then we hit COVID here when we had to go to 100% fresh air on a lot of our air handling units. But we got through that and continued down. And then this is when we commissioned the pellet boiler, the first 3 months. Again, you see how much of an increase we're going up now compared to our baseline. So we're using more energy in the facility compared to our baseline, which is definitely not what we wanted. Ultimately, I ended up in this time frame. We had to communicate what was going on to everyone. So I started sending out emails, and we had meetings to communicate that we were using more energy. We had the pellet boiler manufacturer involved in those meetings. We had the project manager, had the facilities folks, and some senior leadership as well. And I was sending emails with not only the fact that we were going up, but the actual cost increase that we were incurring because of this. So I had to get people's attention, which this did. In the end, what happened was it was a communication error between the pellet boiler and the old oil boilers. So the old oil boilers still are there as a backup. The pellet boiler takes up or accounts for about 70 to 80% of our heating load. But then in the really cold months of January, February, the oil boilers have to kick in just to get us through those colder months. But what was happening was, because of the old oil boiler communication system, it didn't communicate well with the pellet boiler. And ultimately, the oil boilers weren't allowing our pellet boiler to take the lead. And they were just providing enough heat for the heating loop, and our pellet boiler was running, and we were sending heat over to the hospital, and nothing was being exchanged into the heating loop. Took some time to figure it out, but then we eventually did figure it out. March, we actually shut down, so the pellet boiler wasn't running. So this is the oil boilers. You can see here they were firing pretty steadily, and then boom, on around April 8th, we finally figured it out, and the oil or the pellet boiler started taking the lead. This is just a picture of the heat exchanger. So this is while it's working, we're sending 83 degrees C over from the pellet boiler plant, and going back is about 78 degrees C. And then this side is going into the heating loop, of course. So we're coming back from the hospital at 76 and then sending 82 out. But this just showcases the communication that needed to happen to make sure that we solved that problem. And it shows the advantage of all the tracking tools and doing M&V on these projects. It's one thing if you have facilities guys and they knew it wasn't being operated properly, they felt like they were operating two systems, not successfully. But when you actually have the numbers and the tracking tools behind it, it gets more attention and it's easier to get people working on a solution. This wasn't the end of it though for this. We also had some ash auger issues. This is the old design. So we have the ash coming from the pellet boiler, these augers, take it outside, put it into this bin. This was the original design. What was happening though is this motor was overloading on current and shutting the whole boiler down. This happened several times. Facilities guys up there are amazing. Like they come up with solutions to all this themselves. What was happening was we were getting condensation and moisture into those augers, and it was hardening all of the ash. So there's a picture of all the hardened ash, which was what was causing our motor to overload. They'd have to go in and chip out all this ash to get it going again. Again, the facilities guys, they talked to the manufacturer and they said they didn't have this issue at other locations, but eventually they just took it upon themselves to fix it. They moved it inside. So here's the new design. This is an auger just going up, and they have this smaller ash bin here that they have to empty once a day during high load conditions like wintertime, but in the summertime, it's every other day. So it just shows the continuous, effort that's involved to keep these going and keep them going well. So here's the Q sum after, or sort of showing the whole thing. So again, there's our baseline. There's our period where we commissioned it and had our issues, worked them out. Now we're going back down. And along here, there's little events where that ash auger system was shutting us down. So yeah, it just, again, shows the need for these tools and how powerful they can be to ensure you're going in the right direction and you're doing well. Overall, this project saved about $600,000. That's just fuel cost savings. Pellets are cheaper than oil in New Brunswick. It saved about 3,000 equivalent tons of CO2. So it's been a very successful project, and mainly as a result of the facilities folks. These facilities folks also took it upon themselves to clean out. They did a major cleaning of their air handling units. Not always easy to do that, especially in a hospital environment. A lot of the times you can't do them all at once, but they did do that. This was one of the worst ones that they cleaned out. But as a result of that, we increased our airflows, and we were meeting our static pressure set points at reduced fan speeds, which is, that helps with energy. Better for the patients, obviously, and staff. We also, because of this work, were able to do a bit of a mini recommissioning at the same time. Wasn't a full-blown commissioning like we had done back in 2018-19, but we definitely were able to optimize our heat wheels to make sure they're running at optimal conditions based off enthalpy. I'm not going to get into these too much, but we adjusted the air handling unit sequences and schedules. Also optimized some set points to reduce waste energy. And here's the M&V of that project. So here's our baseline. Then we kept going for a little while, and then this is the point when we cleaned our air handling units and did that mini recommissioning project. And you can see now we're going down very consistently. This one outlier was actually an estimate from our MB Power, from our utility. They estimated the reading. So that's why it went up and then went back down a little steeper afterwards. Project saved about 300,000 equivalent kilowatt hours, $40,000 of cost avoidance. The project cost about 35,000, so it was a great project, paid for itself in pretty much a year. And we saved about 90 tons of GHG emissions. It's about the same as 27 cars off the road and about 1,500 trees planted. So that's the first one. Those facilities folks at that hospital, we give out annual energy management champion awards, and they won that award last year because of their hard work, not only to keep the pellet boiler going like they did, but also to do all the air handling unit work that they did, and the little mini recommissioning. So that's the awareness and celebrating them to make them feel like the work that they did was, didn't go unnoticed. And that stuff goes a long way. Second case study is Miramichi Regional Hospital. Called this one the energy or heating fuel energy riddle. This one went on for longer than we wanted. Took quite some time to figure out what was happening, but this hospital has a waste wood boiler, so they have waste wood from Chaleur Sawmills. It's a sawmill that's close by, and that accounts for most of our heating system. You can see here, this is right from Portfolio Manager, this graphic, or this table, I should say. It shows December 2019 and the 12 months prior to that, the cumulative results. So we have about 3,500 gigajoules of oil that we use, but for the most part, our heating is from the waste wood boiler. So 56,000 gigajoules for that time period. But then if you look at 2023, oil, we're down a bit actually, but only 500 gigajoules. So in comparison to the wood, it's not much at all. But the wood is up 10,000 gigajoules. So we're using a lot more wood in this time frame than we expected or should have been. It was up about 20% is how much it was up. So here's the Q sum, or the cumulative sum again. We have a baseline that's quite a bit older this time, 2013 to 2014 was our baseline period. We did some major work with the actual wood boiler at that time, and also did some steam trap surveys, fixed a bunch of steam traps. And so we started saving energy, kept saving that energy all the way up till about November of 2020. And that's when you can see our energy leveled off. So at this time frame, and this is about 3 years, we were using the same amount of energy as our baseline period back in 2013-14, which isn't what we wanted. This added up to be about $120,000 in additional fuel costs. Luckily, our waste wood is our cheapest fuel, so could have been much worse if this, say, were a natural gas boiler. Then it would have drawn much more attention. But ultimately, we did do a whole lack of work. This shows you all the things we were trying to do to fix this problem and couldn't figure it out. We had several boiler outages where we went in and fixed some things with the wood boiler that we thought might have been adding to our energy use, and they didn't seem to fix it. Did another steam trap survey, fixed a whole bunch of steam traps. It was a heat exchanger that we fixed. Long story short, it took about 2.5 years until we finally found 125 PSI main steam line located in the boiler plant ceiling, so 30 feet above the floor. Insulated line. This is the, before the fixes were made. But what was happening was there was a bunch of leaks at all these flanges. This is actually called a Barco ball joint, which is a special joint for expansion and whatnot of the steam. We had to get it redesigned actually because it was original to the building. Took 6 months to get through the design and get all the parts and get the fix. We had to stage up to this, obviously. The reason we found it is because it got so bad that it started dripping down to the floor. So once we saw the condensate dripping down on the floor, that's why we staged up to it and found it. The fix was about $81,000 to get this fixed, but like I said, we were losing about $40,000 a year, so pay for itself in a couple of years. This just goes back into the MNV. So here's the period that we leveled out, and then we're going back down. This is our 2013 to 14, and then we're seeing this green is the savings. So the top blue line is what we would have used had we not done the boiler repairs and the steam trap fixes. Bottom line is what we're actually using because we did those. So the green is a good thing. Had a couple months here and there we had some red. Then we hit this time frame where all of a sudden the expected use and our actual use are pretty much the same. So we're no longer saving that energy that we had anticipated. And then finally, once we found that all those steam leaks at those flanges and whatnot, we fixed them, and now we're back into this green again. And it's gotten even bigger. I should update this chart, but it's got the slope's gotten even steeper as we've gone into the future. And then this is just zoomed in just to show you the capability of these tools. So what I did is just re-baseline. So this baseline is while that leaks were happening up in the ceiling. And then we made the fix. And now, of course, we're going to show that we're using much less energy compared to that baseline while it was leaking. And this just reiterates it. You can see if we had not fixed those leaks, we probably would have used around this top blue line, but because we fixed them, we're using much less. That's that one. Just checking my time. Okay, so St. John Regional Hospital is the last one. This is about keeping up with the small stuff. As we talked about at the beginning, the competing priorities is huge, and things can get knocked down to the bottom of the priority list sometimes, and these tools can help prioritize that stuff so that that doesn't happen. This is passing heating valves that we found. Operators will do their own checks, daily checks of their HVAC unit. I also do them as well because they can get busy. Competing priorities can make it difficult to always get to these things. And a passing heating valve is something that sometimes folks will be like, it's just a passing heating valve, no big deal. But as you're going to see in this case, it can be compounding effects, and it can be more than it appears, sort of thing. Here we have our return air coming in. We're mixing some of that air into our unit. Then we're bringing fresh air in as well. This is the middle of the summer, so it's 23.5 degrees outside. And our temperature indicator before our heating coil is at 22.7. After our heating coil, we're at 26.7. But our heating coil valve is closed. It's summertime, so it should be. We don't want that heat. So we're adding heat to our air handling unit, unwanted heat. On top of that, our cooling coil valve is cranking at 100, so maxed right out, and we're not meeting our set point. Our set point is 13 degrees, and we're only getting it down to about 16 degrees, so we're not meeting comfort levels within the hospital. So my first indication is it's a passing heating valve. Must be some leakage going through there. Also found a second one, same situation. This was another air handling unit, and the same thing going on. We're picking up a little bit more temperature in this case. Still indicating that the valve should be closed on the heating side of things, but cooling valve is screaming at 100, trying to meet our set point, which we're not doing. Graphically, this is some of the benefits of these tools. This just shows our temperature indicator before the heating coil valve, and the top line is after the heating coil valve, and it's showing that 6 degrees temperature increase. Started way back on September 11th. And then it went for quite some time until the 19th when I found it. And again, it's just those competing priorities. The facilities folks have so much going on that they can't always be on top of these things, and it may have got bumped down to a lower priority, so to speak. We did fix it, so I sent these both over to our HVAC tech, and he was able to fix them within a day. And you can see afterwards, all of a sudden now our our temperature indicator before the heating coil and the temperature indicator after the heating coil are the same. So we're not picking up that unwanted heat that we didn't want. This was the other one, displayed a little differently. This one goes back to the start of the summer. You can see here we were, the temperature before and after the heating coil was about the same, so we weren't leaking at that point, but then boom, started leaking. Then it went away, and then it came back. This one, the first one, we just had to stroke the valve 3 or 4 times, and then it was seating itself properly. So that took care of that one. But this one, we actually had to change the valve itself, was just malfunctioning at times. So the heating coil valve had to be changed out. Talked about those compounding effects. So one might think, oh, it's just a small thing when you're passing a little bit on your heating coil valve, so it can wait. We'll get to it eventually. But In this case, as you can see here, this red line, I know it's red, it'd be better if it was blue, but it's the cooling coil valve. And it's 100% open. So we're trying to, bring our, we're trying to meet our set point, and we're not. So it's just remaining wide open the whole time. Then you can see after we fixed it, it dropped down. But if you notice here at nighttime, we actually were totally shutting that valve off. So the cooling coil valve is now completely shutting off. And that's because we have economization or free cooling at this hospital. I think the next one zooms in. Yeah. So here's the end of that passing heating coil valve. So we're still passing on the heating coil valve. Our cooling coil is screaming at 100%. Then we fixed that passing heating coil valve, and boom, at nighttime. And here's this purple line is actually our temperature line. So you can see our temperature was dropping down to 12 degrees, 10 degrees overnight. And that's when we were using the free cooling. So that outdoor air in New Brunswick overnight in the summer, will go down to 10, 12 degrees, and we can just bring that in to meet our set point, unload our chillers, and our cooling coil valve just shuts off. And that's what's happening here. While we were leaking or passing on our heating coil valve, we weren't taking advantage of that free cooling because we couldn't get to our set point. So our chiller was overnight was being loaded higher than we needed it to be unnecessarily. So that's the compounding effects of these things. And if we didn't have these tools to showcase this, it's harder to prioritize things. Just shows it. This is what the operators could see as well. So this is overnight. This is our cooling energy overnight. You can see it's about the same as our during the day on this air handling unit. And this was while that heating coil valve was passing. Then once we fixed it overnight, now we're not using any cooling, unloading our chillers. Then when the temperature goes up during the day, we're using a lot of energy, cooling energy, as expected. It's warmer during the day. I did up the cost avoidance, and if we had left this for a full year, it would have added up to about $6,500 per unit. So $13,000 a year is what it would have added up to. So it's a fairly significant thing. And I did send this out to the whole region sort of thing, to all the facilities folks, just as an example of why we should try to keep these valves working properly. So to sort of wrap everything up here, we definitely do a lot of celebration. It's, again, so important to recognize the hard work that all these folks do, the facilities folks and everyone. We do Energy Star certifications, which is part of that portfolio manager tool. We send those out in newsletters regularly. And I guess an example of how this works really well to raise awareness is these certifications. We had been sending them out since the first one we certified was in 2018. And we'd send out these newsletters to everybody, including, nurses, senior management folks, everyone. And I had gone to another hospital to certify it, and part of certification is a site visit where you have to walk around and do a bunch of light level checks and temperature, thermal condition checks. And a nurse came up to me and sort of said, "Hey, I was just wondering, what are you doing?" And I said, "Oh, we're doing an energy audit just of the hospital, checking light level readings and stuff like that." And she piped up right away and said, "Oh, are we going to get certified to be, like I've seen in the newsletters, to be Energy Star certified as well, like the other hospitals?" I was shocked that, it just shows that they do read them. And she was actually excited that, her facility was going to get certified as well. So celebration and communication is key. You have to do it well, and it's essential for a program to run as best as you can get it to run. So yeah, what we've learned. So it takes time to build trust. So listen first. Trust has to come. You have to have senior management involvement. They need to be aware of everything you're doing and the benefits of it. So you have to do the M&V to sort of showcase to them, and that'll help you get funding and keep things going. Value of how operational, your operational knowledge within your staff. So we have some hospitals where they're just newer staff. The facilities folks are newer. They may not have someone that's experienced there. So you need to focus your efforts a little bit more there sometimes. Whereas we have other hospitals where folks have been at that same hospital for 20, 25 years, and they're just so knowledgeable about the facility that they know how to operate it efficiently. And even when you're trying to do projects, they're just good at it because they've done lots of it. So you do have to know the knowledge of your staff and help you put your efforts where they should go, so to speak. And then one win can shift a team's attitude. So, like I've been saying, celebration is key and highly important to run a good energy management program. And that's it. Hopefully, hopefully we gained, or you gained what I sought out to get, the knowledge that I sought out to bring to you was valuable, and I'm open for questions if there are any.
Awesome. Thank you, Brent. I think, your presentation spoke to a lot of what we try to advocate for at the coalition, including, celebrating the wins and recognizing these amazing accomplishments and all the work that's being done. All it does is encourage more of it to happen. So amazing to see all of the awards and the recognition that your facilities are receiving. And thank you so much. And yeah, let's get into some questions. Um, Everyone feel free to add them to the Q&A. I see we have a couple here already. So Ty Bryant asked, how is utility data most commonly input into portfolio manager, i.e. invoices, consumption reports? What are the common challenges with this?
So yeah, there's a number of different ways you can put the data into Portfolio Manager. You can use spreadsheets. You can upload like full spreadsheets, which makes it easy. You just have to make sure it's formatted properly to go into Portfolio Manager, which doesn't take too much time. You can also do web services. So we have our electric utility in the province, MB Power. They actually upload each month data directly to Portfolio Manager, which that's the ultimate, way to do it because it takes no time. It just happens automatically. And then you can also do the same thing from Portfolio Manager to RetScreen. You can do it manually if you want, but you can also have links where you can take that Portfolio Manager data and it can go automatically into RetScreen. And that's not just with Portfolio Manager. There's other tools as well that folks could be using, and there's the same kinds of connections between the tools. So yeah, as you evolve, you can make it much simpler. We actually have like about 1,000 buildings in the government of Brunswick that we have in this tool, so we have a lot of the automatic stuff just because we have to make it run smoothly.
Awesome. Okay, next question was from David Katz, and he asked, would you be interested in testing new technologies used in hospitals in EU, which I'm guessing is Europe? I wonder if you could say anything in specific in the chat, but I don't know your first thoughts, Brent, with that.
So I'm assuming the question is, like new technologies that are out there, would we test them in hospitals? We do that. So if there's a technology that, we feel could be advantageous to energy, reduction and GHG reductions, then yeah, we'll, meet with those folks. And usually we want to see some case studies where other hospitals or other buildings have used that kind of technology. Hospitals isn't always the greatest spot to try something brand new because it's a hospital environment. You have patients that are getting surgeries, all that kind of stuff in a facility like that. So it's not always the greatest spot to test something that's been unproven, let's call it. So we tend to not do those ones. We want to see that you've proven it in another building or an office building, some building where it's not quite as crucial, that the conditions in the hospital, comfort levels and that stuff. But yeah, we do that all the time, and that's why we do the M&V, so that we can showcase, oh yeah, you know what? They were right, we did save this energy. So then we can implement it in another facility. Hopefully that answers the question.
And that's a really good point to the case studies. And I think, that's again what the coalition advocates for a lot is sharing those success stories and showing like, hey, this is possible. And in particular, we have all of these low carbon energy fact sheets we're going to be releasing throughout the course of this project. And some insider info. We're going to be having these like mini case studies annexes showing all of the little projects that have been done with these technologies across the country.
Mm.
Uh, because, yeah, we want to show where they've been successful, what the benefits have been, and that kind of thing. It is important.
Oh, absolutely, yeah. And the measurement verification, even on the projects that, it's so key because you could try a project and you don't get the savings that you were seeking out. And, if you don't do M&V well, then you may be tempted to go try that somewhere else at a different hospital. And so the M&V makes it so that you can know which ones work and which ones don't, so to speak.
Okay. Well, if there's no other questions, I guess we can wrap up a little early today. Thank you again, Brent, and thank you everybody who joined us today. Like I said earlier, we'll be sharing the recording and the slides, and yeah, please reach out to Brent if you guys have any questions. Um, have a great rest of your day. Thank you.
Yeah. Thanks, folks.
Bye.
Bye now.